Okay, we're going to start working these knuckle motors again. So we got a 46 and a 47. So the 47 is the one I welded all up, and the 46 is the one was a brand new motor. So we got two different cranks for this motors. So we got a brand new S&S crank here, which is, I guess that's the part number for it. So that was I forget what motor we put together. I think it's a stock stroke, I forget. And then over here we got a V-twin crank. That's the part number for them. So we're going to compare these to each other and see what the difference is. See which one's built better. We already know which one costs more. That doesn't mean it's better though. Alright, so the first one is this one. Didn't say the stroke on it, so here's what it is. This is for the 46-inch motor, or 46 motor, not 46-inch. It'd be a small motor. Okay. Alright, so there you go. Brand new S&S crank. All S&S cranks have the numbers, what they are on the flywheels on the bottom. And it's not on the right side at all anymore. Oh, there it is. They change the location. Great. And they laser etch it now instead of stamping in, it'll be there forever. So the 2E right here is the actual designation of what it is. So if you look up the number 2, you'll see what this number 2 stroke is. And E is for early, because early crank, 53 and early. It's got the dowel pins here for the floating crank washer. This has the late style crank pin nano, which is 83 and later. So they're updated. It's got the front and the rear tummy marks. Front, rear, and top dead centers. So it's got all 3 marks on it. Connecting rods are all the same length on these things, so there you go. So that's what that one looks like. Now, are we going to be able to put this in the machine? No, they have a screw right here. You have to take this screw out in order to true it, or to check it. Don't forget not to put that back in there though, because that will be a big, massive oil leak for your very low oil pump. Low oil pressure oil pump. So let's see what it takes to get that out. So we're going to use an impact knocker here with 2 different bits. I'm going to one at once. What's the bigger one? Good. Now, if you don't hit it too hard, it will not affect the crank trueness. Now, easy, this is a left-handed thread, and that's how tight that was. That is not. It was. I just went like that much, and that's about how much they had. That is very, very bad. That could have unscrewed while you're running the bike down the road. That is not good. S&S's quality control sucks on that part. Alright. So let's see if it gets better. So we got our truing stand over here. Go ahead and get this thing over here, and we'll watch the dials go back and forth here, and that'll tell you how good the crank is. Alright, obviously I didn't do a knucklehead last. Probably did my single cylinder bike last. Way different length. move it down a little bit. Used to have some marks I could see over here, but they appear to be gooed out. We can't read them anymore. Yeah, appear to be missing. No problem. Something about there, good. So it's a copy of a rotary stand. It's a CCI Korean one. Way cheaper back in the day. Ooh, if I go that far. Way out there. Nope, we made it. Okay, you want to put that as close to the center of the crank as you can to show the most air. Same on the other one. You can go until the crank pin hits you. Looks like we're clear. S&S is slipping. So you can see they're moving. It's high right there on that side. Looks like it's high right here also. It's just a matter of putting this up on there and giving a little bit of a squeeze job. A little better. This one pretty much quit moving on that side. Let's see if you can really see both sides very well, but gotta look at this needle over here also. It's basically not really moving. This one's moving about half a line. Still high right here. This one's a little high on this side too, so this needs more of a hit. So that means you come up and hit it with your hammer. Didn't move. Hit it harder. It moved. It's high over here now. So now you just give it a light hit to find that sweet spot in the middle. It doesn't really move. If you can find that spot. You can't always find it. It's kind of more over here now. See what the other side's got. It's more on this side. Over here now. It's definitely low right here, which should mean high is here, but Not exactly what I'm getting. About there. So they're kind of opposite each other, so you get a little bit of a twist in it. Which means you're going to support it over here like that. And give it a hit on that side. Give it a twist in it. There you go. That side got better. This side got worse. Ugh. Poke me in the gut. It's right here. Just past center on that one. About the same. This side's a little worse. This is a little bit more past, so it's kind of like a double thing. So you want to hit it here, but you want to keep this side from moving. It's a twist and a bang. This side's good again. This side's still moving around a little bit. It's a cat and mouse game here. High in the center now, which is a good place to be high. And this one is high right there, high right there. It's a double high. So when they're high opposite each other, it's very hard to correct. So it's about the best you're going to get this one. So there you go. Got a little bit better, but this one kind of twitches now. The other one's kind of moving like this a little bit, so it's a little bit better, but not a lot. Not every flywheel you can get perfectly straight. So I'll put it over here, you can see it where they're both moving a little bit, but not a lot. Okay, that's that one. Definitely got a lot of clearance in the bearing. It does slide side to side nicely, which I like. I like 20 thou in play in there, but I don't know. We might have that much. It's close. We do have a lot of clearance this way, which is looser than we normally have it. Now the narrow rod has more because it's half the width. So your indicator is here. See, I'm not moving the rod side to side. I'm moving it side to side at the top. So you got about 50 thou side to side at the top. So it's kind of a little bit on the loose side, which for me is good. Especially these old motors that have bad lubrication, run hot. A little extra clearance is a good thing to have. I actually do like this part. Alright. So I'm going to take this crank, which we just got done truing up a little bit. I'm going to take it apart and rebuild it, because it is brand new. And I definitely trust everything S&S does. So I'm going to take the left side flywheel off. The right side has a key way over here to line it. So the left one's the one you pop off. Inch-and-a-half socket. Big 1.5" zip, or my 1/2" zip gun. Now, S&S used to put a sleeve retainer Loctite on the nut and the taper, so things are pretty tightly put together usually. Let's see if they changed. Pretty tight. You can smell the Loctite and see the Loctite in there. It doesn't look red, so it's probably green. When you look at the color on the thread over here, it definitely has more of a green tint to it than a red tint. See the color right there? Looks kind of greenish. So that should be the sleeve retainer. which was this one right here. It says sleeve retainer right on it. These are the new ones I got here. It's supposed to be a little bit heavier holding power. Debatable if they actually really are though, but who knows? We use sleeve retainer. Now to pop the taper free, right here in the bottom, 180 away from the flywheel, if you know what the crank pin is, with a heavy steel hammer. As long as you hit it flat, with a nice smooth surface, it doesn't really do any damage. Okay, that's not popping because it's extra tight. So now we go over the hydraulic press and squeeze the piss out of it to get it to come off. Put your nut back on there, you don't lose it, doesn't pop off onto the floor, the whole flywheel. So now we go over in the press and we're going to put more pressure on it than we can by beating on it. Now this is typically what you got to do in S&S flywheels because they're built pretty strong. That goes there, that goes there. And I'm still missing my angle irons that go in here. I forgot about that. That's still a problem. You got two pieces of angle iron that go across here that are missing. So I go to these thin ones here, which will have to take up the slack. Actually, I'm not doing that, dumbass. That's for assembly. I'm taking apart. Different combination. Put up in here like that. Slide her over. Push right here. Use a little block if we want. A little pressure on it, like that. You give it a love tap. If you're lucky, it pops. This one didn't pop yet. So we do it again. A little harder. Still hasn't popped yet. Alright. Get my steel hammer and we'll try that one more time. We step the force up a little at a time until it comes loose. You don't start out beating the tar out of it, you start easily and work your way up. Still has not popped, so I'm going to go back to the press and get more active over here. A little bit more pressure over here and hit a little bit harder with a hammer. Still didn't move it. This was being a hard one. Let's move a little bit different direction. Hard of a press. That came free that time. Oh well, that was on there good. Okay, back over here. So you get more and more aggressive to get these things apart. That'd be called a flywheel shift right now. It's moved. Okay. This side just comes off like that. And this side here just rolls around like this. Put it over the end of your table like that. Hold it with your knee. And you can lift these right up like this. And if you had something to stick it over like that tranny case right there, it'll actually stay like that. You won't lose your bearings. Yeah, like that. Now we take this, we go measure these and see how out of round they are. And we have a setting gauge right here so we can see the diameter of what it is too. This is how you check to see how bad things are. Okay, put that right there. So this is an expensive style bore gauge, which measures down to the millionths of the inch pretty easily. Tenth is, each line is a tenth of a thou, which is extremely close. So it doesn't take much air to show something. So as the style here moves back and forth, that's how much it's out around. Oop. So we're looking for size and out around. First thing I do is set the diameter. So I have a setting ring right here, which is goes a tenth of a thou of measuring that diameter. And it looks like we were not using this on the last one we did. So everything is way different. So this is adjustable. See the needle coming up there. Turn 180, check it again. So we're in the middle of the zero like we should be. So we're within 50 millionths of an inch, which is half a tenth. Now we want to see how far out around it is and what diameter this is. So right here we're at 6/10 negative. And this is 1/10 positive. So that's 7/10 out around. That's 3/4 of a thou. That's pretty bad. Two right over there. Turn around, see what it is in this direction. Looks to be fairly straight. It's 6 roughly that way also. This one's 0, so it's 1/10 out around. Or 1/10 taper, which is, that's good. The out around is not good. So the size is pretty big too, but I don't know what the crank pin bearings are, so that could be good or could not be good, but the out aroundness is not good. Now this one should be the same. I don't have room to have everything in here. I don't know how Dad did this without hitting everything. He moved it like this. Okay. So we have to move. This one's too close. It's 2/10 negative there. 3.5 there. 2 there. So that's 1.5 out around. That one's not too bad. I don't like it that bad. I like my stuff within 1/10, but that's pretty good for them. There's 2 down there and 4 there. So half a thou more out around, or half a tenth, excuse me. extra. So this one's honed a lot better as for the out of roundness and straightness. This one's not too bad. You got 2/10 total reading, which is not the best, but for S&S that's pretty damn nice. But the other one's hit 7/10, so I was screwed up. And these are relatively loose too, numbers, so I don't know. I have to go measure more parts to see what the clearance is, but we'll have to see what they are. Actually, that's not loose, that's tight going that direction. So looseness would be going like it is right there. Alright, so that's what the S&S crank looks like. We don't know the size until we do more measuring, but at least you have an idea of the quality of the honing job. So the male rod sucks and the female is not too bad. Alright, so there you go. That's this one here. On to number 2 crank over there. We'll be right back.